In this part 2 of Introduction to Inferential Statistics, I will extend your knowledge of inferential statistics further. In the part 1, you learn the basic concepts of what inferential statistics are. And in this part 2, you will go on to learn a little bit more about in ANOVA and correlation tests. When these results are reported, you understand what they mean. First, analysis of variance, short form ANOVA. When do we use ANOVA? Remember, we use t-test when we compare two groups. But if we have 3 groups, or 4 or 5, what do? We cannot use t-test. In this case, we have to use analysis of variance, or ANOVA. And ANOVA is more powerful than t-test. It does not only allow us to compare only one variable. For example, the number of mice caught by the cats in 3 different groups, but it also can compare another level inside. For example, the experiment on coffee drinking, it does not only allow us to compare 3 groups based on the amount of coffee drunk, no coffee, a little coffee, and a lot of coffee, but it can also help us to compare perhaps the effects of different types of coffee. So ANOVA is a very powerful inferential statistical test. I will not teach you how to run an ANOVA test, but more on how to interpret the results when you see them in journal papers. So let's say you conduct an experiment with 3 groups, and you want to find out the effect of sugar on memory. So you give the 3 groups different amounts of sugar in their drinks. And then after that, you test them on how many words they can remember. Of course, it's good to test them beforehand as well. Now, the 3 groups, one group has no sugar, another group has a little bit of sugar, and the third group drinks a lot of sugar in their drink. And the result goes like this. This is how ANOVA results are reported. There was a significant effect of amount of sugar on words remembered at the p less than 0.05 level for the 3 conditions. Square bracket, f bracket 2, 12, close the bracket, equals to 4.94, p equals to 0.027, square bracket, close. So what you need to understand here is that what is put in bracket after the f signify ANOVA here. The 2 is actually the number of groups minus 1. You have 3 groups, minus 1 equals to 2. Okay, and you see the p equals to 0.027. That is less than 0.05. So the results are significant. That means the amount of sugar has an effect on the number of words remembered. And this is as far as this ANOVA results show. We don't know whether a lot of sugar is good or no sugar is good. So in order to do that, we actually need to run a subsequent test called the Su-Hie HSD test. Okay, by this we look at the mean score. All right, you look at the mean score in the table below. Sugar 4.2, a little sugar 3.6, no sugar 2.2. So when the Su-Hie test was run, the results are given here. Post hoc comparisons using the Su-Hie test indicated that the mean score for the sugar condition was significantly different than the non-sugar condition. Okay, so a lot of sugar is significantly different from the no sugar condition. However, a little sugar condition did not differ significantly from the sugar and the no sugar conditions. What does this mean? It means that the no sugar and a lot of sugar conditions, there will be a difference in the number of words remembered, but the intermediate condition has no effect. And you can see that based on the means, 4.2 for sugar, apparently it is good to have drinks with a lot of sugar because it will help you to remember more words compared to taking plain water that is not sweet, according to this set of results. All right, that should be enough for ANOVA to help you to interpret the results. Let's move on to correlation test. This is a bit different. It's not about finding differences between groups, whether it is 2 groups, 3 or 4. This is about finding out whether there is a relationship between 2 variables. Example, do people who talk more debate better? Because both are some kind of talking ability, just that one is done informally, another one is done in formal conditions with these rules. If somebody tells you we get positive correlation, what this means is that people who talk more debate better. Negative correlation means that people who talk more are actually worse debaters. No correlation means there is no relationship between liking to talk and debating skills. So with this general idea, I hope it will help you to understand what I have to explain next. So we use a correlation test if our research is designed to find out whether there is a relationship between variable A and variable B. So whether a change in A actually goes with a change in B. I'm careful here to not use the word cause, but it's only associated with or linked to or influenced by, because we don't do experiments and therefore we cannot use the word cause and effect. It's only covariation, whether the 2 sets of scores vary together. This is how correlation test results are reported. There was a positive correlation between lecture attendance and course marks. R equals to 0.985, N equals to 90, and P equals to 0.04. So this result shows that increase in lecture attendance is correlated with increases in course marks. So let's look at all these figures. What do they mean? R equals to 0.985. This shows the correlation coefficient, which is between 0 and 1 or 0 and -1. So 0.985 is very high, okay, almost 1. All right, so a very strong correlation. If you attend lectures a lot, you are going to get high marks at the end in the course. N shows the number of students or tags. Here is 90 students. P shows the percentage of error tolerated. So here is 0.04, smaller than 0.05. We always say P must be less than 0.05 for it to be significant in social science research. So 0.04 is smaller than 0.05. That's why the correlation is significant, and in this case is positive. This is what a graph looks like if you plot it. With an increase in the number of lectures attended, there is also the increase in the course marks. When X increases, Y also increases. You can see that in the dots in the middle, it goes up like that. The gradient is positive. It means that students who attend more lectures have higher course marks. Next, negative correlation. Now you see that the line goes down in the opposite direction. The gradient is negative. Surprisingly, with students attending more lectures, the course marks actually dropped. Okay, all right. So the R equals to -0.08. Negative shows the direction of the correlation or the relationship. 0.08 shows the strength of it, which is very strong. You see a straight line, almost straight line. Okay. And finally, no correlation. What does it look like? You say, yes, I can see some kind of pattern like the mountain or upside down V. Yes, but remember when we run correlational tests, we are running tests to find out whether there is a linear or a straight line relationship. So in this case, it is not a straight line relationship. You see, when X increases, Y increases, and then decreases. So when you calculate it as a whole, R is only equals to 0.2. The value is too small. The strength of the correlation is not there. It's so close to 0. So there is no link between the number of lectures attended and the course marks. Maybe it's due to other reasons, such as students' intelligence, the students' effort on their own, etc. So this is a case when there's no correlation between the 2 variables that are studied. And finally, when you use correlational tests, you need to be careful when you write the results, whether it is writing the aim of the study or reporting the results. Remember, correlation shows that two things happen together. It does not show that one causes the other. Only experiments can show cause and effect. Eating more fruits, better skin. Yes, maybe eating more fruits cause you to have better skin or leads you to have better skin, but that is under experimental conditions. If you just run correlation, you can only say there is a link between eating of fruits and skin condition. There are two types of correlation tests actually, depending on the type of data you have. Pearson correlation is if you have continuous data, just such as the weight and the marks, which goes from 0 to 100. And 100 marks is double that of 50 marks. So this is the continuous variable. If you have these two sets of this kind of data, you can run correlation, the Pearson correlation test. But if you do not have continuous variables, you have ranked variables, you can run Spearman correlation test. If you have one variable that is ranked, another one that is continuous, you have to use Spearman correlation test. What is a ranked variable? It means that you assign numbers to the data. For example, in terms of income groups, you can divide them into 5 levels here, 1 for lower income and 5 for the highest income. But 4 is not double of 2. Okay, so this is rank ordered and you need to run Spearman correlation. In research, we very often want to find out whether there is a correlation between demographic variables and certain opinions or certain actions. So correlational tests are important. So I hope with this explanation, you will be able to understand when other people report correlational tests, and hopefully you get to a point where you are able to run correlation tests yourself. Thank you.